Hello, we are Team 20, also known as Perfect Precision. I am Aiden Keough, majoring in aerospace engineering.
I'm Erikson Allen, majoring in chemical engineering.
I'm Katelyn Yunt, majoring in aerospace engineering.
And I'm Molly Hungate, majoring in civil engineering.
When we first started the design process, we wanted to identify how we're going to make a precision launcher. So we looked at the rubric and how much we had to do, and we saw that we were going to make a foam bullet travel to 30 feet. So we looked at, what we got to research, and then we decided, what is the most popular way of doing it, and we saw Nerf guns. So we imagined a whole bunch of possible solutions to the thing, pressurized air, crossbow, but we decided on a lever action spring. So we pull it back, use the spring to launch the dart. That's our solution that we selected. Next slide, please. And the first thing we did was we made a CAD drawing. We modeled the whole thing as we like it. And you see that in the next slide. We saw it and we visualized how it would look in person. Then we designed a prototype in person. Two of us went and we actually made a product that wasn't too far from the CAD drawing. And as we tested it over and over again, and we got consistent results. So we got it to where it could fire those 30 feet and we could meet that target. And over the next 2 or 3 weeks leading up to FEDD, we improved on it. We got those little tweaks ironed out so that by the end, we got something that we are pretty proud of as a group.
So this is kind of a look at those CAD drawings Erikson mentioned. This is kind of an early idea of our design. You can see we had 2 vertical leg pieces and then 1 horizontal piece where the barrel and spring assembly plus the weight was housed. This design changed a little bit through the process. We strengthened some pieces and simplified some pieces for manufacturing, but in general, this is still the core idea of our design.
As mentioned before, it was kind of like a bolt action where you pull it back and it the holder locks in, and then the weight's dropped and it propels forward. The 2 major energy sources that were being used were the weight and the spring, the weight pulling the spring back onto its main track so that it could launch it, and the spring compressing back so that it can launch the bullet.
Then here's a look at some of the actual pictures of our prototype at the beginning of our testing phase, as well as just kind of in the middle of the design. On the left, you can see we have our prototype. We definitely strengthened the legs. That's kind of the biggest difference. We switched it from those 2 vertical pieces to 4, as well as switching our idea from using like wood glue or something, legitimately bolting them in, generally just to strengthen it because we kind of found the spring was a little bit strong. So we wanted to make sure everything was as secure as possible. And then for simplifying, we got rid of that whole idea with the groove. Katelyn will talk about that. And then we just kind of used some brackets. And then on the right, there's a short video of our first test shot. And then, yeah, so with that, you can just kind of see generally how it worked. You pull the spring back, you push down a dart, and you release the spring, and it comes out the end. Pretty simple.
So some of the challenges that we faced, there were multiple different ones that happened, but we were able to fix all of these and find solutions for them. So the first thing was the stability of our stand, like Aiden mentioned a few slides back. We found it was a lot easier to have multiple beams on the ground instead of just 2 little pegs coming down, because this would increase our stability significantly and increased our surface area through that. So when we pulled it back, we didn't have to worry about stabilizing the bottom of the stand, and we could just focus on making sure everything is lined up so that it can launch properly. The second challenge we faced was connecting the PVC pipe to the piece of wood. In our CAD drawing, we had it so that we cut out a semicircular sort of slot for it to go into, but in reality, this would be extremely hard to do and take a lot of time. So instead, we took brackets and attached it over the PVC pipe and then screwed those into place. And it actually ended up to where we would if we needed to change anything on the inside of the barrel, we could just loosen one of the screws of the bracket holding it in place and then easily move anything in and out that we needed. Finally, we had to fix the orientation of our cut. In the CAD drawing, it is shown on the top, but in reality, we would need the slot that it slides through to be on the side and where the latch is on the top so that it works with gravity with the string pulling it down.
If there was any advice I would give first-year engineering students, it would be to meet with your teammates first. You know, you may think that you have plenty of time to do all this thing later, meet with them later, get all your stuff done later, but meeting with them at the first time that you have, so you can see how much workload you can take and how much the project you actually want to focus on at any given moment is very helpful to the project as a whole.
Yeah, kind of relating to that, just starting earlier, because you never know if there's going to be a life emergency before FED. And so just being prepared before that and not doing everything the last second.
If I had any advice, I would say to start testing a lot earlier because there are things that can only be accounted for once you start actually going through with your process.
And then, yeah, just building on that, I'd recommend starting early so that you have a working prototype, and because things are going to break, things aren't going to work how you planned it. So start testing as soon as you can and be prepared for FED and know it's going to work.
And then these are our citations.